Hi, in this video, we will discuss about how we are going to distribute the attributes among satellite. So generally, we have seen that when we create any hub or we create any link, for those hubs or links, there will be some satellite table. So there may be multiple attributes which we have to keep in the satellite table. So the only decision is how we decide whether it should be one satellite table or multiple satellite table, that we are going to discuss in this session. So as you can see on the screen, I have taken one uh, hub customer table, another is a satellite table. So you can see in this, I have taken multiple attributes, like some of the attributes are related to personal detail, you can say customer details. Some of the attributes are related to the customer address. And there are attributes which are related to the customer contacts, like phone number and email ID. So as of now, what I've done is I've kept all these attributes in this satellite table, but this is not a proper approach because this satellite table has the issue of data redundancy. For example, if suppose a customer has a three address. Now, if you are going to keep this satellite table structure, then for three customer address, we have to repeat some data, like customer name has to repeat three times, date of birth, gender. They will repeat three times. So because for each customer, name, date of birth, and gender will be one. But addresses are three, so there will be three records for address. So this data has to be ready. So basically has to repeat. So this will create a lot of data redundancy, assuming that if there are many details like this name, date of birth, or gender, so it means those attributes will repeat as many times as the address is repeating. Or for example, if you take mobile number and email ID, if suppose we need to maintain multiple mobile number for a customer and multiple email ID, then also this data has to repeat. So by seeing this table structure, we can easily understand that this satellite table design is not a proper design. Means it is a lot of data redundancy, and also when there is a data redundancy, we know it takes more space, storage space, which is not a major concern for nowadays. But performance wise, it becomes a big issue because you are duplicating the data so many times. So if somebody has to fetch a customer name, so it means they have to write a query. So they will be getting like a 3 or 4 customer name, repeating customer name, which they have to distinct. So it is like additional process of making the data distinct. So because of data redundancy, we find that there are some process which are going to repeat, especially the query process or update process or insert process. They will repeat multiple times. And also there is a confusing data dependency. For example, if there are 3 addresses, 2 mobile numbers, and 1 email ID. So here, like we are going to have a 3 records for address. Now we have a 2 mobile numbers. So this mobile number will be with the first 2 address, or they will be with the second 2 address or third 2 address. So suppose if you are going to keep with first 2 address, it is like address 1, mobile number 1, address 2, mobile number 2. So here basically we are trying to show that, see, this address and this mobile number are related, or you can say dependent. Means indirectly we are saying that this mobile number is attached with this location or this address of the customer. So this type of confusing data dependency also is created when you distribute the attributes in a improper way or wrong way. So you can see I've taken some sample data also at the bottom. You can see like customer name Priya Sharma 3 times, gender is repeating 3 times, date of birth is same, address line 3 because 3 addresses are there. So address line 2, city, state, country, zip code, they might be different, but other details like gender, date of birth, they are repeating. And here I was talking about this mobile number and email ID. So you can see these 2 mobile numbers are there with first 2 address. So it shows that, okay, this mobile number is related to this address, which is not proper or which is not correct. And you can see this email ID is related with the first mobile number and with the address. So this kind of confusing data dependency also occurs when we combine the attributes in one single table. And here, since we are talking about data vault 2.0 raw vault, so as we know that raw vault is basically to keep the transactional data, means historical transaction data, so that down the stream, whatever systems are there, whatever users are there or applications are there, they want to analyze the data, they want to do the reporting, or they want to use in AI or ML, they should be able to get the data at one single place. So raw data vault is basically designed, or you can say is modeled in such way that whatever transactional data are there for the organization from the past maybe 10, 50, 100 years, they should be available in one single location, in one single format. It means one single structure, so that down the stream application, they don't have to connect to multiple sources, they don't have to deal with the multiple structure of data coming in the multiple format. So for that purpose, this raw data vault is basically nowadays a core part of any organizations, you can say, like data analysis. So that is why when we are designing the raw vault, we basically design in such way that data redundancy can be avoided, unnecessary dependency, confusing dependency should not be there, which can create a problem for applications using down the stream. So this is the one fund. Now in second part, we see how we distribute these attributes among multiple satellite tables. So there is one simple method which I use to distribute is basically what I do is I check the entity, like customer hub is basically based on customer entity. So I check the customer entity, means any entity, or you can say any table which is based on the entity, how their relation is with the attributes. If the entity relation with the attribute relation is one to one, then those attributes generally I keep in one single table, which I refer as a detail. So suppose if entity is the customer, my satellite table name will be customer detail. So customer detail will keep those attributes which are relation of one to one. So like a customer has one date of birth, customer has one name, customer has one gender. So here basically we are checking that for each entity, how many values will be there for this particular attribute. If the answer is one to one, then you can club them in one single detail table. That is the simplest way, but it can be distributed. Suppose if the attributes are too high, these one to one relation attributes are too high, means 30, 40 are there, then you can think of grouping. So maybe you find, okay, there are 10 attributes which belongs to one group or category. Maybe you can think of one satellite, other group you can think of other satellite table. So that you can distribute. It depends on the modeler. The second part, you see there is a customer address. So here, if you see the relation between customer and address, like address line 1, address line 2, so there will be many. Means for one customer, there are 3 addresses or 4 addresses. So it is like one customer, many address. So whatever attributes are there for address, they should be in one table, means in one satellite table. So that is why I've taken them in the customer address satellite table. Third is a customer contact. So I took the customer contact and email in a third satellite table, because earlier which I discussed that, okay, I just want to remove the confusing dependency. So that is why I took this mobile number and email ID in another satellite table. But still there is a dependency, means it is like mobile number and email ID are together. So there are 2 mobile number and 1 email ID. So like first email ID and first mobile number. So it will show that, okay, these are 2 dependent, or they are related to each other, which again is not a proper approach. So this is a means one way of designing a table. So sometimes what we do is we know that there are some attributes which are like one to many relation, but number of attributes are very less. So we design this kind of satellite table, which again is not proper, and I don't prefer this approach. Instead of that, what I do is this static table, which is like 1 or 2 attributes related to one particular, maybe you can say entity or group, I keep in a separate table, but table structure I will make a dynamic. So instead of keeping it static, I will make it dynamic. That you can see in the third slide. So here you can see I have taken customer contact. And if you see the table structure, instead of taking this mobile number, email ID, or phone number, whatever, instead of keeping the column name that way, what I'm saying is, okay, it is a contact type where I will keep the values as a mobile, email, phone, whatever contact you have. So you give a contact type. And then what is the contact text? So suppose if it is contact type is mobile, keep the mobile number. If contact type is email, keep the email ID. So suppose in this approach, what happens? If suppose we have a 3 mobile number and 2 email ID. So in this table, you will have a 5 records. So like a 3 mobile records and 2 email. So if you compare with the previous, there will be 3 records, but it will be like 3 mobile number records and 2 email ID with first and second. So it will be showing unnecessary dependency of email with mobile or mobile with email. But in this case, that problem will be resolved. So right side, you can see I've given the static table structure like mobile number, email ID, and then bottom you can see is the dynamic one. So this, whenever you have this kind of attribute dependency, I will always prefer going with the dynamic table structure. But this structure is possible when the number of attributes are very less, and also number of attributes are common for all those different sub entities. Like mobile, you just keep mobile number. Email, you just keep email ID. Or maybe there are two columns. You have a mobile number, maybe mobile type, email ID, email type, something like. So it is like a two columns are there, or three columns are there. Then you can make this kind of dynamic table structure. Means you can say like a contact text one, contact text two, contact text three, like that. So you can create the dynamic column, and you keep the values in multiple records instead of making a dependency. So this is the one simple approach. So basically here the core thing is, whenever you want to distribute the attributes in multiple satellite table, check the attributes relation with the entity. If it is one to one, you can keep them in one satellite table. If it is one to many, then you can take in a other satellite table. But again, those one to many relation, you have to see that multiple attributes are there. So whatever attributes belongs to one group or one category, keep them in one satellite table, and other attributes you take in other satellite table. So that way you can distribute. Now here in this approach, many people what they say is, but number of tables will increase like anything. So it is like in source table we are getting one table from source with these attributes, but here we are making it three satellite table or four satellite table. So here the most important thing is, we are designing raw vault. We are not designing the business vault, or we are not designing the information vault, which are consumed by the end users or end application. Raw vault basically is your data storage. It is like your historical transactional data are stored. So this structure has to be a very flexible, very dynamic, so that whatever sources are coming in future, we should be able to accommodate them in the raw vault. It is not like we are going to disturb the structure, drop the table, recreate the table, or change the table. So that kind of approach should not be there. So that is why we should try to make it as flexible as possible. It means you can say as normalized as possible, so that future changes from the source system can be absorbed within the raw vault. So this has to be in mind. Raw vault is not for the end consumption. Using the data from raw vault, we build information vault for the analytics purpose. Or using this, we build our business vault, which can be used by the AI or ML system. So those are the area where you go for denormalization. You can club the tables multiple into one, but keep the raw vault as flexible as possible. So don't think about number of tables if they are increasing, or number of columns if they are increasing. That should not be the concern when you're designing the raw vault. Okay, so this in this session, this is the fine. Next session will come with some other topic. Thank you.